We'll answer why spiders don't get stuck in their webs later. Stay tuned for more interesting information. Pluto used to be a planet. What defines whether a celestial body is a planet? My generation still hasn't gotten over this whole Pluto thing. We learned that Pluto was the last planet. A tiny, cute, charming little planet, and now it's not a planet anymore. Pluto was discovered in 1930, and until 2006 it was considered the last planet. But a little before that, astronomers started to notice that in Pluto's region there were several other celestial bodies, several other little planets, let's say, very similar to Pluto. If we considered those as planets too, things would start to get out of hand. So they established a strict rule about what exactly a planet is. First, this celestial body has to have enough gravity to be round. If a celestial body doesn't have much gravity, if it's really small, it ends up not being round. It ends up shaped like a potato, like a spaghetti, I don't know, but it's not round. Second, this celestial body must orbit a star, the Sun in our solar system's case. Pluto meets this criterion. But the third rule is that it has to have a clear orbit, meaning the path it takes around the Sun during the year has to be clear. It must have already attracted everything that was there and cleared its own path. And Pluto didn't do that, which is why since then it has been considered a dwarf planet. This story is sad, but the cool thing is that we gained the dwarf planets. We started to notice planets that we didn't even care about before. For example, Ceres is a little dwarf planet that sits in the asteroid belt between Mars and Jupiter. It's also round and was discovered before Pluto. It was considered a planet, but then it wasn't a planet anymore. Nobody learned that this thing was a planet in school, and now we pay more attention to Ceres. So, besides Ceres and Pluto, we have 3 more official dwarf planets, which are Haumea, Makemake, and Eris. These last 3 are really far away, and we still haven't managed to take any close-up pictures of them like we have of Ceres and Pluto. There's still much to explore in the solar system, which is what makes it exciting. Pluto was downgraded, but we discovered the solar system is cooler than it seems. This question is from the Clips channel. How does a capsule wander through space for years and years without running out of fuel? In contrast, a car on Earth can only travel 1,000 kilometers before running out of fuel, and a cell phone's charge lasts just a day. The word telemóvel indicates the person asking the question isn't from Brazil, as Brazilians use the term cellular, but let's proceed. Those capsules that travel through space, they don't have a rocket that's on all the time. Usually, it's only turned on when it leaves Earth. Right after that, it turns off. The difference from vehicles here on Earth is that out there in space, there's no air resistance. So if you push something, that thing will keep the momentum you gave it forever. There are several calculations to consider regarding planetary gravity. Suddenly, you can hitch a ride on a planet's gravity and slingshot, gain speed and all that. But anyway, there's no rocket that stays on the whole time. It's the initial boost, maybe some course correction here and there, but most of the time the rocket is off the whole way. Renato Furtado Jr., channel member, huh? There's always a question for the members here. How do seeds know the right time to germinate? The seed sets an alarm like this. Look, wake me up in the spring. Alarm set for spring. Seriously, the seed has a kind of mini brain, like an Arduino in there, that checks the conditions outside and decides whether to germinate or not. Actually, there are some very simple and specialized cells that analyze the light, the temperature, and especially the humidity. So, if these 3 things are in good condition for the seed to germinate, it gets started, begins to produce a protein that will stimulate germination. Here's another question from a member. Iberê, I've been wondering for a while how we can see what's behind a fan when it's spinning. Shall we test it out in practice? Before we understand how something works, we need to know if it works. So we remove the guard from the fan here. Never attempt this at home. I'm terrified to be near this device even when it's not running. And now let's turn the little guy on to see if it's really possible to see through the blades when it's running. I don't know about you guys, but I can see perfectly through it. You can see pretty well, right? This happens because of a phenomenon in our eyes called persistence of vision. When you see an image, it stays in your mind for a while. It's a really short time, like 60 milliseconds. But this fan is spinning really fast, so you see the background, and right after that you see the blade covering that background. Then you see the background again, and then the blade, background, blade, background, blade, background, blade, background, blade, In the end, the 2 images blend together, and if you look closely, that's exactly what's happening. You can see the blade too, but it looks kind of blurry, right? Because you're seeing it spinning really fast. So you see the background image, but at the same time it's kind of whitish. A safe at-home experiment that doesn't require dismantling a fan and risking injury. I realize I forgot to put the glasses near him after seeing it. To indicate this, you run your fingers in front of your face, like this. You can see the movement of your fingers and at the same time what's on the other side. Why is the volume of rain measured in millimeters? Wouldn't it be better to use a unit of volume? Millimeters are pretty cool. In Brazil it rains a lot at the beginning of the year, so it's common to see on television. Man, it rained 60 millimeters in 2 hours in São Paulo. That's very simple. It means that in a flat area, a layer of water 60 millimeters thick or 6 centimeters accumulated on top. Or you can think of it another way, that there was a 6 millimeter layer of water that all came down and fell there on the ground. Do you know how much water a glass with a straight rim sitting in your yard would collect? 6 millimeters. Or if you think about a pool that was empty with straight edges as well, do you know how much water that pool would collect on that day? 6 millimeters. This measurement in millimeters is very simple. You can apply it to a backyard, to a glass, to a pool, to anything that has straight edges and a flat bottom. But I know something might be going through your mind. Iberê, this doesn't make sense. Because this glass is tiny, the pool is huge. The pool is going to fill up much more than the glass. Let's do a mental exercise with this drawing here. Here's the pool, here's the glass. The glass's mouth, where the rain enters, is much smaller than the pool. But the pool also has a lot more to fill, so it's harder for you to fill the pool. So at the end of the day, on this day when it rained 60 millimeters, if you look at the bottom of the pool, assuming it was empty, okay? You'll have a little bit of water, 60 millimeters of water height, and in the glass, you'll also have 60 millimeters of height. Because if you think about it, we could divide this pool into a bunch of tiny little cups. And in each one it would rain a little, and at the end of the day there would be 6 millimeters of water there. In short, yes, there's a lot more water in the pool, but the height of the water, how much is left at the bottom, is the same height as what's left in the glass. Measuring rainfall in millimeters is simple. Take a glass, place a ruler on the outside, and check how many millimeters the water level rises after it rains. You just can't use a funnel-shaped glass, right? A glass that's wider at the top and narrower at the bottom, because then the measurement will be wrong. In a large city like Sao Paulo, there are areas with more rainfall and others with less. This measurement is an average. To know when it rained at your house, make a homemade rain gauge. In fact, we've already taught how to make one here on Manual do Mundo. Marcela Costa, Iberê, my daughters adore you and love studying. I'm thrilled about that. Videos from Manual do Mundo have often clarified doubts that I can no longer clarify myself. To be honest, Marcela, I don't know the answers to most of these questions myself. I have to research extensively before discussing them. By the way, all the references for our research are in the video description. I'd really like to know if you record the videos from memory or if you have some equipment feeding you your lines. Let me show you something really cool. This is the instrument that's used professionally, so you can read a text while you talk to the camera, okay? It's a way for you to read the text and the person on the other side doesn't know you're reading it, more or less, right? Many politicians on television struggle to talk naturally to the camera and visibly read from a script, while the pros skillfully conceal it. The logic behind this is pretty simple. It's a piece of glass at a 45-degree angle, with the camera behind it, and in front of it there's a device that displays the text. In this case, it's actually a cell phone that we can control remotely with a mouse or a Bluetooth keyboard, and the text scrolls by. So you over there, if you were in my place, you would have to read this text as it scrolls by, and that's where the hard part comes in. Reading text naturally is challenging primarily because the text must be exceptionally well written. It can't have weird words that make it sound like a written text instead of speech. It's also hard because you have to read and speak at the same time without letting people notice. And why doesn't this text show up on the lens, right? The people watching can't see it because the camera is hidden here in this shadow. I'll record here so you can see I'm placing the camera in here. You can see that the glass is really dirty, but you can't see the letters that are showing up because the reflection is only on the front of the glass, not behind it. And this black screen here, this protection, is exactly so we don't see the reflections on the glass. If this cloth wasn't here, look, the image that this phone would capture would be a bunch of lights that are behind me and everything else. Now, do I use this here on Manual do Mundo to record the videos? No. In fact, this thing is all dusty because we haven't used it in a long time. I used it a lot back when we were recording a little series called Curiosity Pill. They were really short videos that explained some fun fact, and we would record like 30 in one day. I didn't have time to memorize the script, and at the same time my speech had to be really precise so I wouldn't go over the time limit, because back then Instagram Reels and Shorts could only be 1 minute long. So I'm going to put a little video from that time here. It's really short, less than a minute, so you can see if you can tell whether I'm reading or not. I'm reading, but can you tell that I'm reading? A fossil isn't a dinosaur bone. You know those dinosaur skeletons that are dug up out there? That's not bone. After the dino died, its body could end up at the bottom of a sea or a lake and get buried there, and over time, the soft parts like the organs and skin would decompose. Even inside the bones, the organic parts like the marrow and collagen would also decompose, leaving only the mineral part, all full of pores like a sponge. And after that, water would seep into those little holes and deposit other minerals there. Over millions of years, this would end up turning into a rock with the same shape as the original bone. And that's why fossils are rocks and not bones. I was going to finish answering, but Johnson called me out because there's another simpler teleprompter I use that's quite different. I don't have much patience for scripted stories when recording, but sometimes memorization is necessary for promotions and such. I frequently make numerous mistakes when recording text, unlike this Iberê Answers video where I only need to redo a few minor segments. And then there's a secret. Look how cool! I'm going to use the phone's front camera, and then when I press start, the text starts scrolling. And then I read the text and talk to the camera. You can't really tell that I'm not looking exactly at the camera, that I'm looking at the text. Yeah, also because most people look at themselves when they're recording and not at the camera. The eyes are slightly off, but it's not noticeable. Of course, it's not that fast. In these apps, you can control the speed, font size, and everything else, but this one I do use a lot to record stories. But let's get to the main question, probably the reason you clicked on this video. Spiders don't get stuck in their own webs for 3 reasons. The first reason is that at the tip of the spider's leg, it has a kind of tuft of hair that keeps it from touching the web too much. It's like it's walking on its tiptoes. The second reason is that they know how to move well on top of the web, avoiding getting stuck. So their movements, including the threads they step on, some of them aren't that sticky. They select their steps carefully to avoid getting stuck, similar to skillfully driving a car through mud without getting bogged down. The third reason is their legs release an anti-stick substance that significantly reduces stickiness. There was an experiment where scientists washed the spider's legs. And in another experiment, they scraped off those little hairs to see if it would stick more. Yes, it sticks more when washing and scraping off the hairs. Perhaps you felt bad about that. They scraped the hairs off the spider's leg, hurting the spider in the process. But this is for research to develop non-stick materials, materials that stick less. Can you imagine having a spider leg pan to fry an egg?